DSPy's modular architecture enables algorithmic optimization of language model prompts and waits through well-defined components that replace handcrafted prompt strings. This framework treats prompting as an optimization problem, allowing modules to adapt to different language models while maintaining high quality and expressive power. We will now examine how to log and track a DSPy model using MLflow, which facilitates experiment management and reproducibility. The code demonstrates initializing an MLflow run and logging a DSPy model with a specified input example, showcasing the integration between these two powerful tools.
Import MLflow. Start an MLflow run. With MLflow, start run. Log the model. Model info, MLflow DSPy log model. DSPy model. Name equals model. Input example equals, what is 2 plus 2?
This code demonstrates the integration of DSPy with MLflow for experiment tracking and model management. The pattern shows how to log a DSPy model within an MLflow run context, which is essential for reproducibility and lifecycle management in production environments. The mechanism uses MLflow, start run to create a tracking context, then MLflow, DSPy, log model to serialize and store the DSPy module. The input example parameter provides a sample input for signature validation, ensuring the logged model maintains consistent input-output behavior during deployment. This approach leverages MLflow's native DSPy support to package the model with its dependencies and metadata. The key benefit here is the seamless transition from development to production. By logging the model with MLflow, you gain experiment tracking capabilities while maintaining the ability to reload the exact same model configuration later. The trade-off is that sensitive information like API tokens must be managed separately, as they're intentionally excluded from serialization for security reasons. This pattern is particularly valuable when working with compiled DSPy models, as it preserves the optimized prompts and weights that result from the optimization process. Let's break it down.
Import MLflow.
Imports the MLflow library for experiment tracking and model management in machine learning workflows.
With MLflow, start run.
Starts an MLflow run context for tracking and logging experiment metrics, parameters, and artifacts. This context manager ensures all operations within the block are associated with a single MLflow run, enabling experiment tracking and reproducibility.
Model info, MLflow DSPy log model.
Calls MLflow's DSPy integration to log the compiled DSPy model, capturing its configuration, dependencies, and metadata for tracking and deployment purposes. The returned model info variable holds the logged model's details, including its input-output interfaces and version dependencies.
Name equals model.
Assigns the string value, model, to a variable named name. This creates a simple identifier that can be used elsewhere in the code to reference this specific model name.
Input example equals, what is 2 plus 2?
Assigns the string, what is 2 plus 2, to a variable named input example. This creates a simple example input that could be used for testing or demonstrating a system's response to a basic arithmetic question. The integration of DSPy with MLflow creates a powerful workflow for managing language model experiments. By wrapping the model logging in an MLflow run context, you establish a tracking environment that captures all relevant metadata and artifacts. The MLflow DSPy log model function serves as the bridge, serializing the DSPy model while preserving its optimized prompts and weights. The input example parameter ensures the logged model maintains consistent behavior by providing a reference input for signature validation. This pattern enables seamless transitions from development to production by combining DSPy's algorithmic optimization with MLflow's experiment tracking and reproducibility features. The trade-off of excluding sensitive information like API tokens is a necessary security measure that doesn't compromise the core functionality of model versioning and deployment consistency.
The run logs the model. The trace forgets the server. Yet the artifact remembers nothing.